This next part, you can try to get as much information out of it before you come and look at the answers. These are problems where you don't have to do the graph first and then the algebra next and then the writing next. You have to go through and explore and find as much information as you can in a way that makes sense to you. When I look at this table, I'm looking for things that have a y value of 0. Why would that make sense? Well, if I think about my y value of 0, that's going to go along my x-axis. Those would be my x-intercepts. Right away, I can see that on my table, that my x-intercepts are at -5 and 1. Those are my x-intercepts. So -5, 0, and 1, 0. Now, my y-intercept is also pretty easy to see because that is when my x equals 0. Therefore, 0, comma, -5. And now I go backwards in my head. Where have I seen my y-intercept? I have seen that at the end of my standard form. Therefore, my standard form, I know it's in the form of ax squared plus bx plus c. That means that c there, that c value is going to be a -5. If my x-intercepts are -5, 0, my factors, when set equal to 0, are going to have to equal -5 and 1. So if I think about my factored form, if -5 is my x value, meaning if my x is -5, can I set that equal to 0, doing my zero product property backwards? So if I add 5, I get x plus 5 equals 0. And I could do that with my 1 as well. If x equals 1, well, subtract the 1 back, and if x minus 1 also equals 0. And if we remember that going into our zero product property, that means 0 equals x plus 5, the factors, and x minus 1. That's my factored form. This really is acrobatics with your mind. But the more you play around with these, the more familiar they're going to get. And, oh, check it out. I actually know how to go from factored form to standard form. That's foiling. That's just multiplying it back out. And, hey, when I FOIL this out, actually, my last term is a -5. So I can multiply x times x, x times -1, 5 times x, and 5 times -1. And I do get this x squared which gets me there's my standard form, and here is my factored form. And it does mention here that you can skip your vertex form unless you're given it. We could go through our evidence here and plug in our vertex into our vertex form. I'm just not going to ask you to do those just for your own curiosity. This one, you have to flip the sign on the x value of your vertex and then square that, and then here's your y value of your vertex. So we need to find our vertex. Yikes, we haven't even done that yet. Now, I can graph these points to get me an idea of what this parabola looks like. Some people are able to look at these numbers and see that they're going down, 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 and then they turn around and they go up, up, up. But if you're not feeling that, go jump over to your graph and plot those points. And so pause the video, come back and look at the points. I should see now that my turnaround point, that vertex there, is at -2, -9. And by looking at my table, that does make sense that my values of my y values are symmetrical as they go away from that x value of -2, which is that's that line of symmetry we're talking about. So let's plug that in. My vertex was -2, -9, and my axis of symmetry is that x value I see in my vertex. And that's all we need on that example.